Hi class, let's take a look at this problem here. We have a human body who has normally distributed temperatures with a mean of 98.23 and a standard deviation of 0.62. A hospital uses 100.6 degrees Fahrenheit as the lowest temperature considered to be a fever. What percentage of normal and healthy persons would be considered to have a fever? Does this percentage suggest a cutoff of 100.6 is appropriate? Okay. So again, I'm going to use StatCrunch to do this problem. Go to Stat, Calculators, and Normal. And they tell me, let me move this up here, they tell me the mean is 98.23 and the standard deviation is 0.62. And essentially we're going to have a cutoff at 100.6. So basically, anyone who is greater than 100.6 is considered to be basically having a fever. And so the percentage of normal healthy persons considered to have a fever is going to be greater than this. I'm sorry, excuse me, greater. Change this to greater than. Okay. And that's going to be, again, 0.00006. So if I move this 2 decimal places, it's going to be 0.01, okay, because if I have to move it 2 places to make it a percentage. So that's 0.006, but they want me to round to 2 decimal places. So that makes it 0.01. Does this percentage suggest a cutoff is appropriate? Well, 0.01%, okay, is substantially smaller than 0.05. Okay, 0.05 is 5%. 0.01% is much smaller. Okay, so is this an appropriate one? I would say no, because there's a small probability well, actually, excuse me, I would say yes, because it is a small probability of individuals actually having a fever. The minimum temperature for requiring further medical tests. Let's look at the second part of the question. Physicians want to select a minimum temperature for requiring further medical tests. What should that temperature be if we only want 5% of healthy people to exceed it? So go back to StatCrunch now, and now I'm going to change this value here to 0.05 since it's 5%. And that's going to be 99.249. So the temperature is going to be 99.25. And if I round that to 2 decimal places, 99.25. And that's it. Thank you.